Hello everyone and welcome to Math Steps. So this is the second part of solving problems involving the area of rectilinear shapes. Now this question is a question from a higher tier, past paper, and let's read. The length of a rectangle is the same as the length of each side of the square. So I'm going to underline each data that we have in a problem that we're going to need to solve a problem. So length of a rectangle, the same as the length of a side. It says again, the length of a rectangle is 4 centimeters more than 3 times the width of a rectangle. The area of the square is 66 centimeters more than the area of a rectangle. Find the length. See, you need to find the length and the width of the rectangle. You must show all your working. Must. It says show all your working. Right. There is no picture in this problem. So what do you need to do? We need to draw the picture and use. You need to sketch, okay? And obviously use the sketching to label the sides, and that's how you make this type of problems more visual and easier to find the solution. So we have a rectangle and a square in a problem, and the length. So let's draw a square. Okay, this is the square, roughly, all right? And it says the length of a rectangle is the same as each side of a square. So it's about as long as this. So this is the side of the square. The length of a rectangle is about, it is the same as, okay? And I'm going to draw now the rectangle here on the other side. This is a rectangle and that is the square. And as you see, I tried to make the length of the rectangle the same as the length of a square. Okay, so yeah, this is the length. There we go. This one here is the length. And this is the length at the side of the square, both of them. Right, now, the length of the rectangle, which means this one here, and I'm going to label them as L actually. This is L, and this is L, this is L. The length of a rectangle is 4 centimeters more than 3 times the width of the rectangle. So I'm going to label the width with W. And according to this one, L is equals 4 centimeters more than 3 times the width. So 3 times the width is a multiplication, 3W, and 4 centimeters more is an addition, so 3W plus 4. See, that means the side of the square is going to be 3W plus 4 as well. Now the area of the square is 66 centimeters squared, more than the area of the rectangle, which means you need to write down the area of the square, which is actually, because L is 3W plus 4, so the area of the square is going to be 3W plus 4 times 3W plus 4, because it's L to the power of 2. Area of the square, I'm going to write it over here, area of the square, it is L to the power of 2, side to the power of 2, okay? Then multiplies 3W plus 4. Just like that. But this actually is equal, is 66 more than the area of the rectangle. How much is the area of a rectangle? Is L times W. L is 3W plus 4. So I'm going to have this 3W plus 4 that multiplies the W itself. But actually 66 more than the rectangle, the area of the rectangle. So plus 66, just like that. All right, so we have an equation to solve. We have a expansion, a double bracket expansion here, and a single bracket expansion. So why don't we expand? Now, to expand brackets, double brackets, now the first element of the first bracket multiplies each term of the second bracket. And the second term of the first bracket multiplies each term of the second bracket. All right, let's multiply. So 3W times 3W becomes 9W to the power of 2, plus 3W times 4 is plus 12W. Now, plus 4 times 3W is again 12W, And 4 times 4 is 16, plus 16. Equals, here we have a single bracket to expand. So W multiplies the 4 and the 3W. So each term of the bracket that is inside the bracket. So this side becomes 3W to the power of 2 plus 4W plus 66. Okay, now I can see W to the power of 2 on both sides. So I'm dealing with a quadratic equation, all right? So what I need to do, I need to, what's on the right-hand side, I get rid of 3W to the power of 2 plus 4W plus 66 from the right-hand side. Get rid of this one because I need equals 0. I need the general form of a quadratic equation, which is, if you remember, is x to the power of 2 plus bx plus bx plus c equals 0. So this is what I'm going to need. So I need 0 on the right-hand side. So I'm going to get rid of the 3w to the power of 2 by taking it away, taking away w, taking away the 66. And of course, I need to take away exactly the same terms on the left-hand side. We could have done this one term at a time, but it is not wrong if you do them all at the same time. It just saves time, minus 66. All right, cross them out, cancel them out. And so on this side, what do we have? We have 9w to the power of 2, take away 3w to the power of 2, and this makes 6w to the power of 2. 12w minus 4w makes 12w minus 4w for 12w plus 12, 9w, 3w, this one should be 9w to the power of 2 plus 12w plus 12, this one here should be w, plus 12w. So plus 12w plus 12w minus 4w becomes plus 20w. 20w, sorry about this one here, okay? And then minus 66 plus 16 becomes minus 50. Equals, all this side becomes 0. So we have an quadratic equation to solve. So now we need to factorize using the skills of factorizing quadratic equations. Now, so we're going to need the factors of 20 to be able to solve this equation. Now, we need two factors of 20 that if you multiply them together, they make 20. But if you add them together, they make 20. But if you multiply them together, they're going to make 6 times minus 50, so minus 300. Minus 300. So if you add, they make 20. If you multiply, they make minus 300, right? Now, so which one are those? Now, it's a matter of two. It could be 30 and 10 and minus 10 or minus 30 and 10. Now, if it's minus 30 and 10, I'm going to write them all, both of them down. So minus 30 and 10, or it could be 30 and 10 and minus 10. Now, if it's minus 30 and 10, now minus 30 times 10 is minus 300. But if you add them together, you're going to give it minus 20. So it's definitely not this pair. In fact, this is going to be the second one. Because 30 times minus 10 make minus 300, and 30 minus 10 make positive 20. So it's 30 and minus 10. So I'm going to split the middle term here. And this is what I'm going to write on this side. So I'm going to have 6w to the power of 2. So plus 20w, instead of writing plus 20w, I'm going to write plus 30w minus 10w minus 50 equals 0. And I'm going to pair them. Now, common factor for 6w to the power of 2 and 30w is going to be 6w. So I'm going to put 6w, open the bracket, w plus 5, right? And then here you put a minus, and common factor of, we have 10w and 50. It's going to be 10, open the bracket, now w, now be careful with the sign, it's going to be plus 5. Why is it going to be plus 5? Because I have the sign, negative sign here that I used. And if I put them on the bracket, then you have to change the sign to be able, so if you expand, for example, then you again get minus 10w minus 50, right? Equals 0. I have a same common factor here, w plus 5, w plus 5. So I'm going to reorganize them as w plus 5 in brackets, open another bracket, 6w minus 10. And this equals 0. Now for these two brackets to become 0, they multiply together. Then we have two solutions. So it's going to be w plus 5 equals 0. Okay. And the next one is going to be 6w minus 10 equals 0. Equals 0. Now, if w plus 5 equals 0, then w is going to be minus 5. If w minus 10 equals 0, then if you solve this equation, if you do plus 5, I'm going to solve it, plus 10 on both sides. So we have 6w equals 10 divided by 6 both sides, divide by 6, divide by 6. And then w is going to be equals 10 divided by 6. If you simplify, it's the same as 5 divided by 2 both sides. Okay, this is a 10. So 6 divided by 2, 5 over 3. Now, so I have here two values of w. One is negative 5 and the other one is 5/3. Can you keep both of them? Can you use both of them? What do you think? Now, if w is minus 5, actually w, we have labeled a width of the rectangle. Can the width be negative? No. So we're definitely not going to take w negative because it won't make sense. So always put it in, when we solve problems with quadratic equation, always put it in context. Does it make sense? No, it doesn't. So the only value that makes sense and we are going to use to find length as well is going to be w equals 5/3. So I'm going to rewrite it again. W equals 5/3 and is in centimeters, so 5/3 centimeter. I'm going to leave it like this because when I find the length, might help. All right, so let's see. How much, so find the length. Now the length is 4 centimeters more than 3 times the width. Okay, so it's going to be length. We have it here. It is 3w plus 4. Let's rewrite. And then we substitute. Plus 4, length equals 3w, so 3 times 5/3 plus 4. Cancel the 3's out, equals 9 centimeter. And this is the length, 9 centimeter. L equals 9 centimeter. Let's have a look at the question again, the questions of the question. Have we answered them all? So it says, find the length and the width. So we found the length, 9 centimeter. We find the width, 5/3 centimeter. So yeah, we have shown all the working out. Yeah, and this is how you find the solution of these type of questions. And this is how you show the working out as well, step by step. Thank you very much for watching my steps. Stay with me. I'm going to explain to you another question that links to using equations when you solve problems involving area of rectilinear shapes. Thank you very much for watching Math Steps and for supporting Math Steps. Have a lovely day. Bye-bye.